Hello, in this tutorial I'm going to show you how to make a Pong game that looks something like this. I'll be using Python and Pygame for that purpose, and it should be fairly straightforward, because Pong is quite easy after all. I'll be going through all of these steps if you want to jump to specific parts. Let's jump right in. If you are new to Python, Pygame is a module that doesn't come with Python, but you can download it for free. That is done either with the PowerShell or with the terminal, depending on your operating system. So start the one you need just like any other program and you type pip install pygame. You should now be seeing a little animation where you can see things are being installed. Once that is done, open your code editor of choice and type import pygame. And if you can execute that code without an error, you are good to go. Before we actually get into the code, let's talk about how Pygame works on a conceptual level. To oversimplify things a little bit, every Pygame code consists of two parts. One part where you set up all your code you need for the game, so your classes, functions, and variables that carry the logic of the game. That is the part that works like any other code. But to actually run the game, you need a loop, which is the second part. Inside of this, Pygame continuously cycles through a while loop, updates the code, and draws the resulting picture. And since that happens many times per second, we perceive this as a moving image. For a simple example, imagine you want to move a rectangle from the left to the right of the screen. In the setup part, you would create a rectangle and give it a starting position and a movement speed. And then in the loop, you would run a function to make the rectangle move to the right by the movement speed once per loop cycle. With all of that established, let's create a basic setup and we'll work ourselves up from there. The code to create a basic window looks like this. First, we import Pygame and sys. Why we need Pygame should be obvious at this point. Sys, if you haven't encountered it yet, is a module to access some more functionality on your system. In our case though, we're only going to use it to close the game once we're done with it, which happens further down here. Next, we have two lines that are important for the general setup. Pygame.init initiates all the Pygame modules and is required before we can run any kind of game, and you always need it for any kind of Pygame code. After that, we have a clock method that we store in the variable clock. I will come back to this in a couple of minutes, so keep with me for now. And in the next few lines, we create the actual window. The important line here is pygame.display.set_mode, which returns a display surface object, which we store in the screen variable. This method can accept a number of arguments for more advanced games, but we only want to create a basic game. All we pass in is a tuple with the width and the height of the window, both of which are defined in their own variables. In this case, I create a window that is 1280 pixels wide and 960 pixels high. And the next line is purely to give the window a title. I called it Pong, but you could put in any string you like. Once that is done, we get to the loop, which is just a simple while loop that runs perpetually. For now, this loop is incredibly basic and only really checks if the user has pressed the close button at the top of the window. How that works is that on every single cycle of the loop, we get a list of all the user inputs with pygame.event.get. Pygame calls all user interactions events. So an event could be a click of a button, a moving of the mouse, or even just closing the window. And we loop through all of those with a for loop. So effectively, we have a while loop that updates the game, and inside of that loop, we have a for loop that checks for all the user actions. For now, all we want to check is whether the user has clicked the little X at the top of the screen, which is a certain type of event that Pygame calls quit. And if the event type equals pygame.quit, we call two methods. Pygame.quit uninitializes the Pygame module, and sys.exit closes the entire program. All you really need to know is that both of these combined close the game reliably. Pygame has lots of keywords to check for different kinds of user input. These are called locals, and they are always capitalized. I'll put a link in the description for all the options. And after the input, we have pygame.display.flip. This method's entire purpose is to take everything that came before it in the loop and draw a picture from that. For now, since we haven't drawn anything yet, it only draws a black screen. And finally, we have clock.tick, the same clock we defined earlier in the code. Essentially, what this one does is that it limits how fast the loop runs, in this case 60 times per second. This is necessary because your computer will try to run the code as fast as it can. So if you don't control the speed, the computer might just try to run it at 10,000 cycles per second, and you wouldn't be seeing anything. And that's it. We have created a basic setup. When I run the code now, we get a black window with a title. So let's talk about how to draw on that. To draw stuff in Pygame, you have to understand a hierarchy of 4 different concepts. The most basic element is the display surface object. We already created this one in the code with pygame.display.setMode and stored it in the screen variable. This is going to be the main screen that we draw all our shapes on. And there can be only a single one. So even if you created lots of shapes and images, unless they are on the display surface, they would not be shown. Now you could draw directly on this display surface with pygame.draw, and you have the option to draw all kinds of shapes. However, there are 2 more elements that make it easier to organize and manipulate all the shapes and images. The first is a regular surface, or just a surface. Think of it like an extra layer that holds material, which is quite useful to keep your game organized. The difference between the display surface and a regular surface is that you can have as many regular surfaces as you like, but you need to attach them explicitly to the display surface. Otherwise, they would not be shown. But besides that, you can basically do the same thing with both kinds of surface, like adding drawings or putting pictures on them. The second element is a rectangle, or a rect. And that is literally what it is, a rectangle. What you do with this rectangle is that you can put it around shapes and regular surfaces, which makes it much easier to measure them and to manipulate them as well. Which becomes really handy when you actually make a game. And that is it. For this game, I won't be making any surfaces besides the display surface. I will, however, use rectangles for the shapes. Let's put all of that into code. I will start by defining a rectangle for the ball. This is done with pygame.rect, which takes in the x and y position along with the height and the width of the rectangle. Keep in mind that the x and the y position is for the top left of the rectangle, and also that the origin of the window itself is on the top left. So if you want to go down, you have to increase y. The ball itself is going to be 30 pixels wide and 30 pixels high. That part is easy. To place it right in the middle of the screen, we do need a little bit of math though. I couldn't just put it at half of the screen's width and half of the screen's height, because I am moving the top left. And if I placed it like that, it would be slightly off the center. But that can be fixed by subtracting half of the width and half of the height of the ball itself. And if we do that, the ball is perfectly centered. Next, I define a rectangle for the player that I put in the middle of the right side, that is 10 pixels wide and 140 pixels high. And I place its top left on the coordinates screen width minus 20. And I get the height with the same method that I get the height of the ball. I divide the height of the screen by 2, and I subtract half of the player's length from that. And then I define another variable for the opponent that holds a rectangle at the coordinates 10 and the same height as the player. And it will also be 10 pixels wide and 140 pixels high. For now, these are just 3 empty rectangles. To actually draw them, we need to get the loop and use pygame.draw, which is the module with all the different options to draw shapes. To use that one, we usually need 3 arguments: the surface to draw on, a color argument, and a rectangle. Since I'm drawing directly on the display surface, that one is easy. And I also have the rectangles I need. So let's talk about colors then. There are 2 ways to create colors in Pygame. The most common one is with a tuple of RGB values. RGB stands for red, green, and blue, and you can set the value of each of these colors. And if you mix the different values of each of these colors, you can create basically any color. Essentially, we have a tuple that we can pass 3 values into. The first one for red, the second one for green, and the third one for blue. And you can choose the values from 0 to 255. With 0 being the absence of the color, and 255 being the pure color. So for pure red, it would be 255, 0, and 0. For pure black, it would be 0, 0, 0. And for pure white, it would be 255, 255, and 255. The other way to create colors in Pygame is with a color object. This one is created with the command pygame.color, and you pass in the string of the name of a color. You can find all of the available color names online. And that's basically it for this one. Let me use both methods so you guys have an idea of how it looks in the code. I will make the background with a color object and use an RGB tuple to make a grayish white that I will use for all the other shapes. So below the rectangles, I declare a variable bg_color and assign it pygame.color and pass in the string gray12. And on the next line, I create another variable called light gray, and I assign it the tuple 200, 200, and 200, which gives us a light gray. With all of that done, we can get into the actual drawing. In the loop, I start by drawing the two players. Since both are plain rectangles, pygame.draw.rect fits really well. I pass in the surface to draw on, the light gray color, and the rectangle. And then I do the same thing for the opponent. Next is the ball. This we draw with pygame.draw.ellipse, which also takes a surface, a color, and a rectangle. But instead of filling the whole rectangle, it uses its frame to draw an ellipse into it. And since all our sides are the same length, this ellipse becomes a circle. And that covers all the main shapes. But I will add two more elements that don't need a rectangle: a line that separates the two sides of the field and the background color. Especially the background color is important because without it, you would still be able to see the previous frame, which would make the game impossible. So I add the background color by filling the entire display surface. This is done by calling .fill on the variable that holds the surface, screen in this case. And into that, I pass the color I want to use, bg_color in this case. And finally, I create a line that separates the two sides. This will be done with pygame.draw.aa_line, which stands for anti-alias line. This one needs 4 arguments: a surface to draw on, a color, and a tuple with the start point and a tuple with the end point. So I pass in screen, light gray for the color. The first tuple will be half of the screen's width and 0 for the middle of the top window. The second tuple will be half of the screen's width and the screen height for the middle of the bottom of the window. And one thing to pay attention to is the order of the code. Successive elements in the loop are drawn on top of each other. So the first element called in the code will be at the bottom of the frame, and the last one will be on the top. If I put screen.fill below the other elements, we would only see the background, so do be careful with that. But if I run the proper code now, we can see that all the basic shapes are there. And with that one done, we can get to the animations. I will start with the ball. Right now, the code works like this. We define a rectangle with coordinates and dimensions, and later we draw the rectangle on the surface with a color. The way we do animations is that we add a step in between that tells Pygame to move the coordinates by a number of pixels every cycle in the loop. And for that purpose, the rectangles are incredibly useful. Essentially, in and around each rectangle, there are these points that we can influence and measure. And if we move a single point, we move the entire rectangle. So for example, if I wanted to move this rectangle to the right by 5 pixels, I could use x plus equals 5, or right plus equals 5, or even left plus equals 5. They would all achieve the same result. And that result would be that on every cycle, this rectangle would move to the right by 5 pixels. So to get the ball moving, I start by defining 2 speed variables, one for the horizontal speed and one for the vertical speed, respectively called ball speed x and ball speed y. And I set both to 7. Why we need 2 will become clear in just a second. Now, in the loop, we want the ball to move every frame by the ball speed we defined earlier. That is super easily done with ball.x plus equals ball speed x and ball.y plus equals ball speed y. So on every single cycle, This ball will be moved by the speed we defined in the speed variables. And since we are doing this 60 times a second, we get a moving image. Let's run the code now and see how this looks. We can see that we have a moving ball, but the problem is that the ball moves out of the frame since we never told it to stop. For that, we need some collisions. Just to get this started, I will let the ball bounce around the 4 sides of the screen, and later we add more code when the ball hits the left or the right side. The basic logic we need is something like this. If the top of the ball is 0, or the bottom of the ball is equal to the height of the screen, then reverse the vertical ball speed. And if the left side of the ball is 0, or if the right side of the ball is equal to the screen width, then reverse the horizontal ball speed. And the reason we have 2 speed variables is to be able to reverse the speed for each axis separately. And since we can access all of those attributes, this is actually a really simple if statement. To reverse the ball speed, all we need is to multiply the speed by -1. And since we don't care if this goes from positive to negative or from negative to positive, we only need one if statement for each axis. And when I execute the code now, we have a bouncing ball. One thing to be careful of is that you shouldn't use the equal comparison. As you can see in my if statement, I use greater or equal or smaller or equal. The reason for that is that we need to be careful of what points we are measuring. If the ball moves 7 pixels per cycle, and it happens to be at the position 955, and then it would move to 962 in the next frame. Since that wouldn't be equal to the height of the screen, the ball would just continue and we would have a game-breaking bug. If we use greater or equal to, then this problem wouldn't occur at all. So this is why I'm using greater and equal or smaller and equal to. But anyway, I also want the ball to collide with the 2-player rectangles. And the rects are great for that as well, because they have lots of methods to measure collisions. We only need the simplest one, where we just check if 2 rectangles are colliding. The method for that is called collideRect, and you call it on one rectangle and pass in the other rectangle. And if they collide, it returns true. And with that, all we need is an if statement with 2 conditions. So if ball.collideRectPlayer or ball.collideRectOpponent. And inside of that, we just tell the ball to reverse the horizontal speed. Just like we did for when it hits the left or the right side of the screen. And with that, we have all the collisions we need. I will do some housekeeping before continuing. Adding too much logic in the loop is going to become quite confusing and also difficult to maintain. And it is usually better to keep all the logic in the setup part and use the loop primarily to draw and update the shapes. So to make things a little cleaner, I will put the ball movement inside of a function and call that function where the code used to be. And I will call it ball animation and put it at the top of the code. However, if I run the code now, we get an error message about some local variables. This can be fixed by including global ball speed x, ball speed y at the top of the function. And let me add a small intermission to explain why this is necessary. In most programming languages, including Python, it is really important where a variable is declared. In Python, you have 2 major spaces, also called scopes, the global and the local scope. If you declare a variable inside of a function, you create a local variable that isn't available in the global scope. This applies even if a variable of the same name already exists in the global scope. So when we try to update the ball speed, we try to update a local variable that Python did not yet initiate, so it threw an error. There are a couple of ways to get around that. One way, like I did in the code, is to declare global variables inside of the function. Unfortunately, this is only a good solution in simple programs. If you attempt this approach in more complex code, you will end up with adding more and more names to the global namespace and make things quite confusing. A better way would be to use either a return statement or to use a class. Especially if you use a class in the global namespace, then its attributes can be updated within the local scope. As a matter of fact, when we moved the ball, we did just that. Hope that clarifies things a little bit. Back to the game now. Next up is the input. There's one input command already, that you can close the program by clicking on the little X at the top. I will expand this, and what I want is that by clicking the up and down arrow, it moves the player in those directions. This requires to check two events actually. First, that a button is pressed down to start the movement, and second, that the button is not pressed anymore and that the movement should stop. Pygame can handle both of these easily. We just need to check the event type for pygame.keyDown and pygame.keyUp. I will start with keyDown, which is for pressing a button down. But this one only checks if any key on the keyboard has been pressed down. To check for a specific key, we need another if statement inside of this if statement that checks for event.key. And the down arrow is called k_down in Pygame. And inside of this if statement, we can add code to execute when the down key has been pressed. You might be tempted to just add something like player.y += 7. But that would not work. You see, Pygame only checks if the button changes the state from unpressed to pressed. So if you keep it pushed down, it will not trigger the event. You would need to continuously press the button to move in tiny steps, which would not be fun at all. There are a couple of ways to solve this. The one I found the best is the following. You declare a variable player_speed and add this speed to the player rectangle on every single cycle of the loop, regardless of what button is pressed. That being said, if no button is pressed, this variable is 0, so the player effectively doesn't move. However, when the up or down key is pressed, this variable becomes positive or negative, and then the player will move. So let's put that into code. I first declare the variable player_speed and assign it the value 0. So back in the loop, I add player.y + player speed. Now to the input. Back in the event key if statement, I change player_speed to += 7. And I add a second if statement that checks if event key equals k_up for the up button. If this one triggers, the player speed should be -= 7. And after all of that, I add the if statement for releasing the button. I can just copy the entire statement from key down actually. All I need to change is that we reverse the operation. I change key down to key up. So -7 becomes +7 and +7 becomes -7. And with that, we're done. If I run the code now, we can move the player. But there's one small problem. The player can move outside of the window, which is a little bit annoying, so let's fix it. All the logic I need is that if the player's top is smaller than 0, to put the player's top at the location 0. And if the player's bottom is greater than the screen's height, then to put the bottom at the screen's height. That way, the player will always be placed back at the border if he tries to go over it. We basically teleport him by such small numbers that it looks like that there's no movement at all. And again, this starts to look a bit messy. So I put all these lines into a function I call player_animation. And no need to declare global variables. All of this should still work perfectly fine. And with the player input animation, we almost have a game. But we still need an opponent. I will keep this one simple. If the opponent's top is above the center of the ball, move the opponent down. And if the bottom of the opponent is below the center of the ball, move the opponent up. And the speed of the opponent will be used to determine the difficulty. It's pretty simple actually. In the code, I declare a variable called opponent_speed, and I set it to 7. And in the loop, I add if opponent.top is smaller or equal than ball.y, then opponent.top plus equals opponent speed. And if opponent.bottom is greater or equal than ball.y, then the opponent.y minus equal opponent speed. I also want to prevent the opponent from leaving the screen, so I implement the same logic that I used for the player just a second ago. And again, I put all of that logic into a function and call the function in the main loop. Running all of that basically gives us a working game. It's not much fun though because nobody can lose. So let's finish the game with that one. All I really want is that once the ball hits either the left or the right wall, I want it to return to the center and restart in a random direction. We already have code that checks whether the ball hits the left or the right side. It's in the ball movement function. Within that, I remove the line that reverses the speed of the ball and replace it with a function I call ball_restart. And further down in the code, I create that function and add the details. The first thing we need is to teleport the ball to the center. This is actually quite easy. We did similar things already loads of times. You see, for now we only ever added small increments to the number by using plus equal or minus equal. But we don't need to use that. We could just assign a number immediately and teleport the ball around. Exactly what I want to do here. So on the first line of the function, I add ball.center equals screen width divided by 2 and screen height divided by 2. Note that this one needs a tuple and that we move the center of the ball, not the top left like we did in the beginning, which makes the math a little bit easier. And running that code already gets us kind of a working game. But the ball keeps the same direction after the goal was scored. To fix that, I need the random module. So at the top of the code, it is import random. And back in the function, after the ball was centered, I add the vertical ball speed and type multiply equal random.choice and insert a tuple with positive and negative 1. And after that, I do the same thing for the horizontal speed. Random.choice selects a random element from a list that is passed into it. Basically, after the ball is teleported to the center, each speed variable is multiplied either with 1 or minus 1, thus randomizing the direction. The one thing we need though is to declare both speeds as global variables. Don't forget that. And while we're at it, I can also multiply both speeds when they are initially set with positive or negative 1, so that the ball starts in a random direction at the beginning of the game. That being done, we can run the game and we have a really basic Pong game. And granted, it's pretty basic, and you could add lots of things, like a timer before the ball starts or a score, and some sounds might be a good idea as well. But it is a working game to get things started. So I hope you liked this tutorial. You can download the source code from the links in the description. And if you want me to explain how to add these parts as well, just let me know in the comments. Otherwise, for next week, I'll be showing you how to make a calculator in Python. I'll see you then.